Welcome to our lecture online, and now we're going to take a look at factoring. It's not going to be a complete coverage of factoring, but a good representation, some basic factoring that you should know going forward. First of all, there's some general theories of some very common or very typical kind of things that you should factor. For example, the difference of squares. A squared minus b squared will always be factored as a plus b times a minus b. Of course, this could be x squared minus y squared. It would be x plus y times x minus y. Same thing. What if we have something like this? This is considered a perfect square. It'd be the first term squared, the last term squared, and twice the product of the two terms. So that becomes a plus b quantity squared. And if it has a minus here, that would be a minus b quantity squared. So these are perfect squares, and that's how you factor them. What if you have the sum of cubes and the difference of cubes? The sum of cubes is factored as follows. This is if it's a cubed plus b cubed. Oh, and this should be cubed, not squared. A cubed plus b cubed, this will be a plus b times the quantity a squared minus ab plus b squared. In the case of the difference of cubes, it is a minus b times a squared plus ab plus b squared. Notice it doesn't have a 2 in front of there that you see over there, but don't be fooled. It doesn't need it when we do the sum and the difference of cubes. And then you'll run into some special cases. For example, sometimes you want to factor out a common factor first. So in this case, you can see that 2 is a common factor. So this can be written as 2 times, you have x squared minus 7x plus 6 remaining. And let's see if that is factorable. It turns out, that's not even factorable. So at least that's as far as you can go. In some cases, you want to do some substitution. For example, when you have x to the 4th plus 5x squared plus 6, notice that this is x squared and this is x squared squared. So you can do the substitution like let y equals x squared. And then the equation becomes, or the expression becomes like this, and this is easily factorable in terms of y, and then you revert back to x. And sometimes you use a special technique, especially in the case where the coefficient in front of the x squared is a large number. What you want to do then is write it as an expression of 4 terms. You take the middle term and you write it as 2 middle terms. And the way you find the coefficients of those 2 middle terms is you know that the sum of the 2 coefficients should add back up to 2. That has to be, of course, the case. So you know the sum of the 2 coefficients is 2, and the product of the 2 coefficients that you're looking for, the 2 middle coefficients, is equal to the product of the outer 2 terms. 15 times minus 8, like this, which is minus 120. So can you think of 2 numbers, when you multiply them together, you get minus 120, and when you add them together, you get 2. Now you realize that there must be a positive and a negative number, and the difference must be 2, because when you add them, the positive number should be 2 bigger than the negative number. When you multiply, you get minus 120. That's beginning to sound like 12 and 10. So in this case, that can be written as a positive 12 times a negative 10, which is minus 120. And so that means that the middle term will then become plus 12x minus 10x. And then you group them in 2 groups of 2 and factor out a common factor from that. And we'll show you that example on the next video. Just want to make sure that you should memorize these general ones, because these are very straightforward. And then the special cases, you have to use some other technique sometimes where you have to factor out a common factor first, use some substitution method, or use a special technique when the coefficient in front of the x squared term is very big. If you want to see some examples, go to the next video and I'll show you how to apply these special techniques. See you then.